So it's the squeeze theorem that gives us these. Okay, where we can actually find the limits. You can also find the limits of each of these numerically and graphically. Numerically is like creating a table for it, and you'll see that the limit approaches 1. Graphically would be, you graph it and you can see that the limit approaches 1. So because of these, because we know these, we can answer problems like this. We just have to make this look like one of these. Now this one has the sign in it, so I'm assuming it's going to be this one. All right. Now a better way to look at these theorems would be as the limit approaches, as the theta approaches 0, sine of something over something equals 1. Now those somethings need to be the same thing. Okay, whatever it is. All right, so if those somethings are the same thing, then we can use this. All right, so how would we change this so that the somethings would be the same thing? Let's see. It says the limit as h approaches 0 of sine for h. So our something right there is for h over h. Are our somethings the same? No. And I put those parentheses. Those parentheses are extra. If I want to have a 4 right here, I can multiply the h by the 4. But I can't just do that. I can't just multiply the bottom by 4. What would I do? I would also have to multiply a top by 4. So if I multiply a top by 4, now I have a 4h on the bottom and a 4h on the top in my somethings spot. Now what about that 4 though?
Can you factor that?
Yes. Now the laws of limits say that if you have a scalar in there, a scalar is like a factor that you can take out, just a constant number. You can take the scalar out, find the limit first, and then you multiply the scalar to it. So we're going to find this limit first of sine of 4h over 4h. And our theorem says that this equals 1. So then you go 4 times 1, which would be 4. And that's how you find your answer. That's a good question. Okay, so to answer your question, what if we treated 4 like it's a function? Then you would write it like this. You would say the limit as h approaches 0 of 4, and that would be multiplying times the limit as h approaches 0 of sine 4h over 4h. So what is the limit as h approaches 0 of 4? Now 4 is a constant function. You guys know what constant functions look like?
Straight.
At 4, we have a straight line. Okay, so if I approach 0, this would be my h in this problem. If I approach it, actually if I approach any number, what's it going to equal? 4. So this is kind of unnecessary for constant functions. That's why I just wrote it like this. But your question was, what if it didn't say 4? What if it said 4x? No problem. Then what you would do is, instead of taking the limit as you approach 4, it'd be taking the limit as you're approaching 4x. Does that make sense? This is a law of limits. Law of limits says that if you can split up a function, you could take the limits of each of those functions to find your answer of the main problem. Does that make sense? Here, check it out. Pull out your practical notes. Well, the laws of continuity are kind of the same as the laws of limits. This just says, like, if f and g are continuous, then all of these functions would be continuous. If you add the f and the g, that would be continuous. If you subtract, if you multiply, if you divide, if you plug them into each other, if you raise them to a power, it would still be continuous. The idea with limits is that if you have a function that is 2 different functions adding together, you can break them apart and find the limit of each of those functions. And then, in this case, you would add them together. So let me write something out here. If I had, let's say we had the limit as x approaches something, we'll say a, of f of x times g of x. And you can see, oh look, there's 2 functions in there. I can split them apart. You can find the limit as x approaches a for f of x, and you can multiply it times the limit as x approaches a of g of x. That's what a basic law of limits says you can do. And that's what I was referring to earlier when we took out the 4x. Okay.